Welcome to the studio. You're listening to Willow Waves, a student-produced podcast where kindergarten through 6th graders explore interests, promote solutions to global concerns, and communicate about everything related to our social and emotional learning.
We aim to amplify voices, share knowledge, and encourage conversations. Visit us at willowspringses.fcps.edu to learn more and subscribe.
Join us as we explore our diverse and dynamic world of elementary education.
This is a story of how wind energy saved an entire village.
In the early 2000s, a 19-year-old boy named William who lived in Africa went to the library and saw an image of a wind turbine. His village was dying off and they were in the middle of a huge drought.
He decided to build one, and for practice, he lit up 3 light bulbs in his house with it. This proved that it could work. He and his town together helped to build more. They then took that energy and used it to help grow crops in his town.
Once upon a time, around 3,500 years ago, before Christ, wind energy was harnessed and used.
The technology began to advance as time went on. Then in 1887, Charles F. Brush invented the thing we will be focusing on today.
The great and mighty wind turbine.
Wind turbines have 3 blades that spin and harness the wind and turn it into wind energy. If you think about wind turbines, you probably think about a big pole with spinning blades that you see sometimes in the distance, which it is kind of. But you have no idea how they are. They are huge. So huge that just one blade, can be up to 189 feet long. But that's not what we are focusing on. Our focus is on the good things about wind turbines and the energy they harness.
A lot of trees are cut down, producing CO2, and CO2 can kill many animals, and cutting down trees can take away their homes.
This is what happens when we use non-renewable resources, not just fossil fuels or CO2. But we have a solution to that: wind energy. Coal and CO2 are 2 of the most used non-renewable resources and also one of the most polluting.
That's where wind energy comes in. Wind energy reduces CO2 by a lot and produces around 11 grams of carbon dioxide per kilowatt, which may seem bad, but think about the fact that coal produces a whopping 980 kilowatts.
Wind energy is also very important for many other reasons. One being is that is one of the most renewable resources, and we have basically unlimited amount of it. It can never run out and can be used for many, many things that are very important to us. One main thing being the fact that it is a very reliable source of electricity. We use electricity in our daily lives, and it is very important to us. But fossil fuels are being used to produce it, which is causing more CO2 to be released into the air.
But today, we have a very special guest to help us explain it better. Meet Dr. Stewart. Thanks for being here with us today.
Thank you. Happy to be here.
Now we have several questions for you to answer.
Okay.
So the first one is wind energy cost effective?
So yes, I would say wind energy is the type of thing that it's very variable depending on where you are. So you can be, standing between some buildings and it's not very windy, and then you step out from behind those buildings and it's very windy. So it's very specific in terms of where you place a turbine, whether it's going to be cost effective or not. But generally, all the projects that you will have seen built, if you've driven by and seen any locally, or just pictures and knowing that they're kind of all over the place, any project that's been built is cost effective. There's a lot that goes into deciding whether a site is a good site for a wind project. It takes years of planning and trying to basically understand that question: is this going to make money? And they wouldn't build it if it wasn't going to make money with very, very high probability.
That's interesting.
That's very interesting.
Yeah.
How do you deal with wind energy mostly being located in remote sites?
So there are places where there is a lot of wind energy and it's not remote. I think wind projects tend to be in remote places partially because sometimes that is where the wind is, but partially because you're trying to capture the energy from the wind. And if you have buildings in the way, that's going to cause a lot of turbulence, and you're not going to be able to as effectively extract that energy out of the wind. So they don't usually put big wind turbines in urban environments, partially because of that reason. Although there are building integrated wind, there's other technologies that they're talking about doing that with. But so it is basically, from a wind project development perspective, the developers are looking for places where there's a lot of wind and there's transmission. So, the grid, the big power lines traveling across the country. So if they can build a project even where there might not be any population, but there are power lines going through the area, then they can get that power to places where there are a lot of people. And then they add transmission lines, sometimes so that they can access more windy locations to get that power to the people. And then all along the east and west coast, you've got a lot of population, and we're starting to look at offshore wind, which is much closer to those coastlines than some of the windy sites in the middle of the country.
It's pretty cool.
Yeah, it is. How are wind turbines transported from place to place?
So they have all the different pieces are separately transported. So you'll have the blades on one big long truck. The tower, sometimes that's in sections, and then they'll build it up on site. And then the big, we call it the nacelle. That's the piece that you attach all of the blades to the rotor, which is connected to the nacelle, and that's got all the machinery in it. So all those things will travel separately to the site, and then they will be built kind of like a Lego, just a very large one on site, connecting all those things together.
I bet transporting, like having to transport one of the blades, they seem really long, so I would be really scared if I was driving the truck transporting it.
Yeah, the blade wouldn't live if I were driving.
Terrifying.
Yeah, I haven't seen one lately, but a long time ago I saw one traveling on the road. And if you think of it just being sort of like on the back of a truck in the place of, the rectangular shipping container, that's one way, but they're getting really, really long. If you Google videos of wind turbine blades in, especially in other countries, you'll see trucks that have them then tipped up at an angle so that they can, at an angle, and then they can navigate corners more effectively. And they might even be able to swing it around so that they have a lot of operability of moving the blade while it's driving around, like up mountains and things like that. It's pretty cool.
So this is in one of the questions on our list, but is it really dangerous to transport a wind turbine?
Okay, so I would say there are professionals who know how to drive vehicles that can keep those components safe. There's probably a little bit of risk to that. In mountainous locations, which is kind of where I am, they do actually consider helicoptering in components. And usually that is not the most cost-effective solution, but it is something that they might consider too if you have to get into hilly terrain, whether you want to build a big road going to that location, or maybe you just lift things and then bring it to the site. That, I would say, is dangerous, more so than traveling on land.
That is very fascinating.
Yeah.
Could they just make the trucks that carry them off-roading trucks that they don't have to make roads, but they can still drive it across?
It's tricky. It's not entirely, the issue is not entirely bringing the components to the site, but bringing the crane to the site that's needed to then build it all together. They have to bring a very, very heavy crane onto the site, like a 1,000,000-ton crane. And so even if they can get all the components there, they need to get this on a off-road type site, the road. They need to build a pretty significant road infrastructure to get that very heavy crane in there.
Wow.
Yeah.
So our next question is, once the wind turbines are in the ground, do they ever get moved?
No, generally no. So they're usually designed to run for 20 to 25 years. And we're just starting to see some projects installed in the US that are about that old. And instead of moving them, they're more likely to keep the tower there, but maybe put new blades on the machine, or replace a few components, but keep it going in the same location.
It's pretty cool.
Oh, what is the likelihood of a wind turbine falling down? And what if you do it if it falls?
So it's pretty unlikely. And because they are pretty remote, there's actually no, it's not kind of the same sort of situation than if, I don't know, something in a city would fall down. It wouldn't be typical that people would be there and that there would be an impact. But the situations where you might see something fall would be like a very, very windy environment, like a tornado or a hurricane coming through. They're generally designed to withstand that sort of force. So something else might be happening at the same time that might cause it to fall down. So it's not absolutely impossible, but it's very, very rare.
Have you ever had, do you know about like a wind turbine falling, like a wind turbine that you know about?
Not any that I know about like that, no.
Wow, they must be pretty stable then.
Yeah, so the towers are usually made of steel. And that's very, very strong. And the sections are bolted together in, a whole bunch of bolts are there holding it together. And then below the ground is a ton of concrete. And have you heard of rebar? It's like reinforcement bars, like basically just metal bars that are kind of spread throughout that foundation before they pour the concrete on it. And that helps keep it very solid on the ground. And then you bolt the tower to that. And so it's pretty structurally safe. It's the blades that have more flexibility to them that, generally have more problems than actually the tower falling for any reason.
Wow, that's pretty cool.
How do wind plants impact local wildlife?
So I'm going to separate that into wildlife that I think of as like deer, squirrels, things like that, and then avian life, so things that are birds and bats and flying. With wildlife, just during construction, they obviously might be scared away, but generally from the projects that I'm familiar with, I think the environment has actually returned to a more, they might plant things, where they've kind of torn up the earth, that those species would be actually happy, very, very happy with, coming to graze and spend time there. And so there's not a huge long-term impact with wildlife that are on the ground. Avian species, so birds, generally don't have a huge impact by operating with modern wind turbines today, but they've taken a really bad rap for the past, where in the 80s in California, they had turbines that had these lattice towers. So not this tubular steel structure that you see today, but towers that birds would kind of be attracted to come sit on the tower. So that would bring them to the turbine. And they were smaller and they would spin a lot faster. So there was a lot more avian impact then. We've learned a lot from all of that early experience. And the only times when birds are really impacted by wind turbines is mostly during like very foggy environment, and buildings are just as likely to have birds, fly into them as a wind turbine in that sort of low visibility environment. Now bats are very special, and they tend to like to frolic around wind turbines because they're really high up, and they like to kind of play around the highest structure in the area. And so occasionally, while they're frolicking and having fun, they might get hit by a turbine blade. And that's something that the industry is very seriously trying to reduce. And there's ways that they are looking into making that impact much, much smaller. I know that was a long answer.
like seriously hurt? Would it just be like, ow? Okay.
Sorry, what was that?
Did the bat get like seriously hurt?
It could, yeah. If it got hit by the blade while it was moving, yes.
Like sharp?
And it's not so much as sharp, but something that's kind of moving kind of fast could hit it, pretty hard, and then they fall to the ground, and they might not survive the fall too. Yeah. So, yeah, bats are special because they eat all the things I don't like, mosquitoes, bugs, stuff like that. So, and they also, when they have babies, they usually only have one at a time. So it's hard. If you kill a bat, it takes some time to kind of repopulate the species, and they're being impacted from lots of other industries. So I think they're very special for a variety of reasons, but that we're trying to reduce that impact.
That's pretty cool. Our next question is, do the wind turbines, do they like produce a lot of noise?
So they do produce noise, but pretty much everything produces noise. I don't know if you have I guess you're all on computers right there, but there's a fan in your computer. I don't know if you guys notice the sound of that fan. I usually refer to, like, if I'm in a lecture hall, I'll point to the projector in the room, and the noise coming from the fan and that projector is about the level of noise that you experience from kind of standing near a wind turbine. It's not super loud in terms of its actual level of noise, but it's got a periodicity to it that I relate to like a ticking clock. So if you're alone in a quiet room with a ticking clock, it can be annoying. Tick.
But it's
tick.
like quiet for its size.
It isn't the noise usually that is the actual issue. It's the regularity of the noise. And I relate also to like the waves crashing at the beach, which nobody generally complains about that sound. It's got some regularity to it, but is not quite as specifically regular like the wind turbine blades passing the tower. That's what you're mostly hearing, is that shoo, 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 the sound. When I first took my son to a wind farm, he thought it was like a plane passing over in the sky, over and over and over again. That's sort of what it sounds like in a distance. But if you are used to it being very, very quiet, and you fall asleep nearby, and you have your windows open, and then this is a new noise that's been introduced into your environment, it can be irritating from that perspective.
How does wind power benefit local communities?
So often in reality, the power itself will kind of go to the local community, but usually the people who are paying for it, it's just a paper transaction, so it could be almost anywhere. But projects generally bring a lot of money to the community through taxes that entity would have to pay. That it'll also, usually most wind projects are put on private land. They're not actually owned by the company that's developing the project. They'll lease the land. So there's the landowners who are actually involved with the project can help support keeping that land in their family, and it's a way to generate money. So it's sort of another way of farming the land, you could think of. But so generally it supports that there's money that flows through the community because of the project being there. That can support schools and local infrastructure.
That's cool.
Yeah.
What are you most excited about for the future of wind energy?
So I like to remind people that wind energy is actually a form of solar energy. So this is a source of energy that we receive every day from the sun. It heats up the earth unevenly, so that's what drives this difference in the wind flow. Goes from hot to cold, and then we've got pressure differences as well, and the earth's spinning, so it gets really complicated quickly. But generally that uneven heating of the earth's surface is what drives the wind. And I'm excited about the use of wind energy in that it is a renewable energy. It's something we receive every day. I think ultimately we're going to find that we can power all of our human energy needs from things that come to us every day, which generally is from the sun. So that's my favorite thing about it.
Like, could wind energy like replace the fossil fuels?
Generally, yes. So wind, I wouldn't say just wind, I would say wind, solar. Also, energy storage will be very important because since it's not windy all the time, the wind changes, from 1 hour of the day to the next. Having the ability to store energy is very helpful too. Hydropower also is a good, another renewable resource, which is also solar derived. So that's from the sun heating the earth and water evaporating and then falling on higher surfaces and coming downhill. You can get that power out of the water too. So all of those things working together could generally replace fossil fuels someday, but it'll take us some time to get the whole way there. And energy storage will be needed to do it.
Yeah, that's super cool. Why do you think it's important to educate other people about like wind energy and the importance of wind energy?
So there's a lot of misconceptions about wind energy in particular. I guess I find there's misconceptions about everything out there. So it's important to be diligent when you're learning things, to look at all the different perspectives and look at relative comparisons between things. So I think also acknowledging that technologies improve with time, and that these industries are learning from previous experiences. It's important to kind of get an understanding of where both the technology is now and its path to get here, and recognize that it's not just like one instant moment in time that you can form an opinion about something, because things are going to be improving and everybody's going to be learning from past mistakes and making improvements, and things it could look very different in a few years. But generally, I think it's important that people have that approach to learning about anything. It's that you have an open mind and you understand all the alternatives too.
Yeah, that's important. That was our last question.
Okay.
And I really learned a lot, and this is a really interesting conversation. So thank you so much for being here. It was a pleasure to have you here.
No problem. I'm happy to answer any other questions you might have at any time. And I know you looked me up and you know who I am, but just so you know, I'm a faculty member in aerospace engineering here at Penn State, and I do a lot of outreach K through 12. We have a Kid Wind competition here. I have colleagues in Virginia at James Madison University who are really excellent. So if you haven't connected with them, that might be another good resource. Happy to connect you to anybody if needed, but just let me know.
Yeah, thanks.
Thank you.
All right. Well, great job. You guys did a very good job articulating your questions. So thank you.
Thank you.
Should I sign off?
Yes.
Yes. All right.
That's the end of this episode of Willow Waves. We also learned a lot with our interview with Dr. Stewart. Let's review what we learned.
We learned that wind energy is super good for the environment and help reduce the amount of CO2 released into the atmosphere.
We also learned that it can have multiple effects on the environment. It can be neutral to the animals on the ground and allow them to graze around it, but it could harm many bats and birds. Thankfully, they are coming up with solutions to that. We also learned that wind turbines are transported with long trucks and maybe even helicopters if there are no roads for the trucks to take.
What else did we learn? What do you think the most important thing about wind energy is? What are some solutions you can brainstorm that solve the bat problem? What else do you know about wind energy? What do you like about our podcast? Think about it. Thanks for listening to Willow Waves, Wonders of Wind Energy.